Okay, so do you guys have any questions or doubts in the last session which we had yesterday, or shall we start with the next one?
No doubts.
Okay, fine. So yesterday we understood about the button interface or the sensor interfacing. So now we are going to make few advancement in the same topic. That was button interfacing, where we used only one button and one LED. So when we turned on the button, the LED was on, and when we turned off the button, the LED was off. This we did with only one button and one LED. Now today we will try to make a keypad. But before that, first we will add one more button in the same program which we did yesterday. That means two buttons and two LEDs. So firstly, let me open the same circuit which we did yesterday. That was uh, one button and one LED. So which one was that? P6, I guess. Yeah, this we did yesterday. And also I'm going to open the same code so that we can complete it as soon as possible. If I started from the very zero, that means we need to write the whole code again. So let's say, I guess it was P5. Let's see if it is the same. Yes, this was the code which we did yesterday for one button and one LED. I told you about the concept of masking. So int x equals to pin A and 0b000001. That was the part of masking because we are using only one button. So we need to keep all the port pins as 0, and where we are using button, we not need to keep it 0. This we did because I told you sometime it may happen that there is any logic in any of the pin of your port, and when we are comparing any of the codes like this one or this one, it won't get true logic because of the previous logic of any other pin. So we did masking to 0 the previous logic of that port. Now, when we are using two buttons today, so first of all, let's complete the circuit diagram. So let's pick one more button, and this I am connecting with pin number 39, that means port A1, and this pin, let's connect to power only, and let's take one more register for this button and this one to ground. So register was required because the button was having power source at one pin and other pin was directly connected with the microcontroller, and just because of that we were not getting any ground logic or any zero logic. So when we compared, if button is on it was working, but when button is off it was not working because it was not having any ground logic. So that's what we did here. We connected this register with ground so that the pin of your port can also get one logic and zero logic. Now on the output side, we have to connect one more LED. So let's connect LED to pin number 22, which is called port C0. And then let's go to the code, and I'm changing it a bit. Let's copy the whole code and write a new project. And it's P6. The same device at Mega 16. Let's select the whole code, delete and Control V to paste. Now we have same port A as 0, same port C as output, where we connected the LED. And here we need to give 1 because now we are using 2 buttons. Except those 2 buttons, we have 6 free pins available in that port, which means if we have to mask, we have to forcefully zero the logic of those 6 pins. We have to forcefully zero the logic of those 6 pins, except port A0 and port A1, where we connected the buttons. Now, when we compare, the first one is this. When the first pin is on, the LED is on, and then when the second pin is on, let's turn on the second LED. So we are using 2 buttons which are connected at port A0 and port A1. And if the button connected at port A0 is on, then the first LED is on. And when the button connected at port A1 is on, that means button 2, then the second LED is on. Now let's write more conditions. What if both the buttons are on? So suppose if we want, if both the buttons are on, turn on both the LEDs. So let's write the code for that. Else if x equals to 0b 0 0 0 0 0 0 1 1. That means both the buttons are on. So now let's write port C equals to 0b 0 0 0 0 0 0 1 1. Both the LEDs are on. So here I just wrote both LEDs on because in the condition both the buttons are on. Now we have to add one last condition, that if no button is on, neither first one nor the second one, then we have to turn off both the LEDs. So we have 2 ways to write this code. Either we can use the else loop. That means if the condition 1, 2 and 3 are not satisfied, it has to run the else loop. And in else loop, I am simply saying port C equals to 0b 0 0 0 0 0 0 and 0 0. That means turn off all the LEDs. Or otherwise, the second way maybe like else if, when we will have to write the condition. If we use else if, that means writing the condition is mandatory. But if we do not use if with else, then we don't have to write the condition. So if we write, what to write? X equals to 0b 0 0 0 0 0 0 0 0. That means both buttons are off, or otherwise we can do it else only. That means if first condition is false, second condition is false, and the third condition is also false, that means there is no button on. So we are done with the coding part. Let's build the code and check it's working. So let's go to the simulation, double click. It already has the file location, but that it has for the P5, and we just change the project to P6. So let's browse and change the location to P6 now. So in P6, we have a debug folder. Let's select the hex file and click OK, and then click play. So now let's see if the first button is on. Okay, it's turning on both the LEDs. Fine. Why? Because what we did, we connected the second LED with the same port C0, and we have to connect it with this port C1. Okay, now let's repeat. If button 1 is on, the LED 1 is on. If button 2 is on, the LED 2 is on. And if both the buttons are on, then both the LEDs are on. Any questions? Any doubts? Okay, fine. So let's now start the topic which I told you, keypad interface. Let's try to make a keypad, and especially num keypad I'm talking about for now. We will be doing one numpad where we have total 0 to 9, 10 keys. That means if I want to type 0, I have to press a key for 0, and then if I write 1, I have to press a key for 1. So that means now we need to use total 10 buttons. Total 10 buttons. So how to do that? Firstly, let's change the project file, and let's say at mega 16 we need, at mega 16, and we need button, we need register, buttons we need to make the keypad. In actual we have keypad available in the library of this Proteus, but I am not using that keypad because we haven't achieved the level of programming of keypad till now. So we can do that later once we start programming in loops like for, then if we understood arrays and all, then only we can do the keypad interface where we will be using keypad as a library component. But for now, I am making my own keypad using 10 different buttons. So let's pick all the components fastly. Button, and then need register. Now, input side is done. Let's do something for output. That means if button 1 is on, we have to print suppose 1, then where we have to print this. And in the same way, if we are pressing the key for number 8, it must print 8, but where? So for that, we are using 7-segment displays, because we know in 7-segment display, we can write the alphabets and the numbers as well. So currently we are making numpad. So let's use 7-segment common cathode. Also, we understand when we do the programming of this 7-segment display, it's difficult for us to make the combinations for each number. Also, the second thing is that we will have to use total 7 pins of microcontroller to give the logics to these 7 pins of 7-segment display. So I told you about that also. If we want to reduce the number of pins interfacing with 7-segment, then we can use an IC called BCD to 7-segment display 4511. So now we will be using 4511 for this, and it will also give us a benefit like when we have to print 1, we are not required to make any combination like turn on the segment B or C. Then if we have to print 2, we are not required to make the combination to print 2 to turn on A, B, G. So it's not required. We don't have to make any combination. We can simply use the hexadecimal codes. And this we can do if we use IC 4511. So whatever number we want to print, we can simply write the code like 0x01. So let's connect all the components together. Output side is very easy, but input side is, although it's easy, in the input side is also easy, but we may face difficulty or a bulky circuit, because this time we have to use total 10 buttons, and if we use 10 buttons, that means 10 registers are also required to connect with them. So first I'm completing the output part. So let's connect these 7 pins of IC 4511 to the 7-segment common cathode display. And then let's connect a ground to the common pin of your common cathode display. And now let's give pin number 22 to 7, 23 to 1B, to C, and to D. So we are using only 4 pins of port C, and those are port C0, port C1, and port C2. Then we already know about it, that we have to give the logic 1 to lamp test pin and bit inverse pin, and we have to give the logic 0 to latch enable pin as its active low pin. Now let's create the circuit for the input side where we have to make a numpad. So manually I'm making it by using 10 different buttons. So 3, 4, 5, 6, and 7, 8, 9, and 10. Now let's connect the first one to port A0. In our port, we have only 8 pins starting from port A0 to port A7, but the number of buttons are 10. So definitely for remaining two buttons, we will have to use for remaining two buttons, we will have to use another port, which is port B, and there we can use two different pins, PB0 and PB1. So 8 buttons are connected properly, and those buttons are now connected with port A0 to port A7. Now we have last two buttons, and I'm connecting them with port B0 and port B1. So always try to make your circuit as clear as possible, and it can be done only after practicing. If you do not practice on this software, definitely you will face a lot of issues connecting the components, deleting the lines, connecting the wires, and everything. So you have to do practice for many times for the same circuit or for number of circuits. So now I'm connecting one pin of button to the power. So if the components are arranged in the same manner, what I mean by same manner, like if this component is just above to this component and the dimensions like on the grid are same, then we can simply double click here. If we double click, it will automatically connect to the same wire. But it's true only when the wire length is same. What I mean to say, in this case, we can see the wire is not connected properly. The wire is not actually connected with these two. And why so? Because I just double click, but component was not exactly placed above the last one. See, I'll show you by example. I'll zoom it. Suppose I have 4511 and then I have a 7-segment display. So
Sir, I
here,
have a
yes, please.
sir, the program which we are writing here, it is same for all microcontrollers.
No,
Okay.
this method is for at Mega 16. 8051 is almost same. Then after this, we will start another controller programming, which is completely different. But yes, the simulation circuit is going to be the same. The hardware is going to be the same, except your controller. Just you need to change the controller, and most of the things will be same. That also depends
But
upon. Mhm.
but sir, method are same or not?
Methods are same, logics are same. That's why I said the hardware is same, the circuit is same. And if we are writing the logic, that is also same. Just what we can see, like they have different syntax. Like let me give you example. If you heard about the programming which is called assembly language, and if you have to turn on or if you have to give any logic one, there you have a program or there you have a command like move a comma 1h. That means move one value to register A. And here we are writing port C or port A equals to 0B00000001. So here we are writing in terms of port, there we are writing in terms of a pin. Here we are writing using C embedded programming, and there we are writing using the assembly language. But what is the common thing? In both the places, we are writing the 5 volt, we are writing the one logic. So the logic is going to be the same, hardware is going to be the same, even the circuit is going to be the same. But what is going to change? That is the syntax of your programming.
Okay, sir.
Yeah. Okay, so I was telling you about the same length of wire. What we can do, we can connect them uh, by shortcuts if all the wire lengths are same. For now, in this example, all the wire lengths are same because all the pins are just all the pins of 7 segment are just opposite to IC 4511. And if first is connecting very straight, then second obviously it's going to connect the straight way only. So let's simply double click. Again, see, I'm just connecting one wire and then I can double click and I can see it's connecting directly to the 7 segment. And even if we try to reposition this, we can see all the wires are connected. So this is the best way to check. Drag your component and see if all the wires are connected. That's what I did here. I tried to move this wire to check is it connected or not. So I just drag the wire. I can see two wires or two buttons are not connected. If I'll do Control Z, yeah, I can feel that this one is not connected just by this, but this is looking like connection, but still it's not connected because the wire length was not same. So if your wire length is not same, I'll not recommend you to double click on the component. Simply create the wires individually. So we connected all the buttons together with one point, that is power source of 5 volt. Power source of 5 volt. Now we have one last component to attach here, that is register. After this, the circuit is going to be very bulky. Till this, it was very easy to create. Now let's connect 10 different registers with all the buttons. So I am dropping it just after one, and then we will connect them. The first one, the second one, the third one, the fourth, fifth, sixth, seventh, eighth, and ninth. And then let's drop one more, 10th one. Done. Now we have to connect all the registers with ground. So let's connect the registers with each other in
Sir,
this
here
way.
in
Mhm.
register, sir, in register, how we can assign value in register?
Like for now, if we see this register, it's 10 kilo ohm. And if I want to change it, I can change it like this, 220 ohm. This you were asking?
No, sir. मतलब
So
यहाँ
you
पे
mean to say,
value कैसे decide?
one sec, I'll interrupt you. You mean to say how we decided to use 10 kilo ohm resistor here in this circuit, correct?
Yes, sir.
Okay. See, actually the concept of connecting the resistor is very simple. When we, okay, let's wait. First, let me connect all these resistors and then I'll make another circuit to explain you this thing. So I just connected all the resistors with uh, internally. I mean, I connected all the, I shorted all the resistors with each other, and now we have to ground them. So let's connect a ground with it. Fine. Now let's come to your question. So for this, I'm using another Atmega 16, another button, another power. So first, we need to understand why we connected the register. Can you tell me who was asking? I guess Ashutosh, right?
Yes,
Yes, Ashutosh, can you tell me like why we connected this? Like what is the need of register? Why we connected the register in this circuit?
sir. To oppose the current.
To oppose the current. No, see, actually, you know why? If we connect the ground, directly to the button, and if we keep it on, this logic 1 has two paths to travel. The first path is this one, and the second path is this one. The first path is this one, and the second path is this one. And we know current always choose the shortest path to travel. So if we do not connect the register
Yes, sir.
here, your logic 1 will travel towards the ground. It will never reach to port A0, to pin number 40. And we need the logic at port A0 as well. That's why we are not connecting this ground directly. We have to insert one register. So now this is clear why we connected register. Now let's understand what should be the value of register. So suppose if we have connected a register here, one second. During the screen share, sometimes it does not work properly, this Proteus. Okay. So now I connected one pin of your register with ground and another pin with the buttons. And now again, let's talk about the same logic. When you turn on the button, this logic 1 is going to travel and it has two paths to travel. The first one is the shortest path which has resistance. So it will try to go to another path, because the basic rule or the fundamental of your current is that it chooses the shortest path with minimum resistance value. And here we can see the resistance is connected. So it will try to go to the another path, which is pin number 40. And this way we can see the logic 1 at port A0 or the logic 1 at port A. This way we can see the logic 1 at port A0 or logic 1 at pin number 40. Now, if suppose I connect here 220 ohms, and this 5 volt of logic is traveling, and it has again shortest path of this resistance, and 220 ohm is not too much, because if we pass the 5 volt and we want to block the whole voltage, 220 ohms is not enough. So 220 ohm resistor will allow your current to flow through it. But yeah, it's obvious it will not allow the 100% of the current flow through it. It will allow something like 80% or 70% or 9%. So that means what I want to say, you may face the leakage of current if you connect the short or small value of your resistor. So I'll not recommend you to use 220, 330, 500, 600, 700, 800. Yes, you can connect 1 kilo ohm resistor. If you want to know the exact value, then you need to calculate it using Ohm's law and Kirchhoff's law. And also, we must have how much current we are getting from this power source. Then only we can calculate it easily, because V equals to IR. We know we must know I, then only we can we can calculate the R. So I hope you got the basic idea why we use this value.
How we can find I, sir?
How we can find I?
Yes,
Simple.
sir. Yeah.
Battery source.
Because we know only 5 volt.
It's battery source. Whenever you will be using a battery, it must have a current. We get the batteries using according to the current ratings, according to the wattage. If the current is not mentioned, the power will be mentioned there. Let's suppose it's
Okay, but
Mhm.
it's all depend on your battery.
Yeah, obviously, because this is the power source which we connecting directly, the battery source. And if you say
Okay, I
that
understand.
and if you say that we will give this power source from the output of microcontroller or from any pin of microcontroller which already has the 5 volt, that time I'll tell you the current will be only 20 milliampere, because all the pins of your controller provides 20 milliampere current.
Okay.
Okay. So that depends if you connect internally or externally. External source has its own power and you can calculate the current accordingly. Internal source means the controller provides 20 milliampere per pin if the voltage is 5 volt and 50 milliampere per pin if the voltage is 3.3 volt. Okay. So now we are done with this simulation and let's go to the programming part. So I'll not make the whole program because you have to make it by yourself. But yes, I'll try to include 2 or 3 buttons working here. So it's P7 and 16. And then I'm writing DDR. So we have used 2 ports, port A and port C. So DDR C equals to 0B 11111111 because this port we are using as output. And DDRA as input where we have total 8 buttons connected. So let's write 0B 111111. Sorry, I'm so sorry. It must be 0 because these pins will work as input. 00000000. And we have used port B also because two buttons are connected to port B. You can see it. 2 buttons are connected to port B0 and port B1 respectively. So I'm writing the code for DDR B as well, which is 0B 00000000. That means need to define the whole port as input. Now let's come to while loop where we have to first mask the port. So int x equals to pin A, and we have used all the pins of pin A and total 8 buttons are connected here. So let's mask it with 0B 11111111. So this time we not need to forcefully zero any pin because we have all the pins connected. But with port B, only 2 pins are connected, that is port B0 and port B1. So forcefully, we need to make the logic of other pins as 0. So let's take another variable for this, y equals to pin B and 0B 00000011. So let's forcefully zero the all pins except port. Sorry for the interruption. Yes. So I just masked 2 variables, x equals to pin A and all pins as 1 because we used all the pins here, and then 0B 00000011 because only 2 pins are connected here. So it's very simple now. Let's write if condition if x equals to 0B 00000001. So that means we are going to turn on this button, which is connected with port A 0. So let's write it roughly. Suppose we are making this button as 0, this button as 1, this button as 2, so this button as 3. Write by yourself for all other buttons because we don't have enough time to write this. We have to focus on coding as well. Come back to this. If the first condition is satisfied, then let's write port C equals to 0B, or simply write in hex code 0x00 because this button was for 0. Now, else if x equals to 0B 00000010, that means the second button is on. So this time we have to write 1. So port C equals to 0x01. I'm writing the code in hexadecimal so that we not need to make the combination. Else if now suppose I'm doing it for another button which is connected at port B0, this one, and I'm considering this for number 8. So let's write the code for this port B0 and port B0 masked and stored in the variable y. So what we need to compare here, y equals to 0b 00000001, the first button of port B. That means pin port B0, and that means variable y is high. So port C equals to same 0x08 because output is at only one port, that is port C. So now we are done with it. So let's build the code, go to controller, double click here, change the path as the program is being changed and it's P7, and let's run the hex file. So it's 0, it's 1, it's 8. We didn't added another pins in the coding. So you need to write it by yourself. 0, 1, 8 are working absolutely fine. That is it for the day, guys. Okay. And I record all the sessions, but as I said, yes, already that I will not record, sorry, I will not upload all the sessions to the YouTube channel. For that, I will ask all of you to create your account on our web portal, and we will give you the access of the course there for the lifetime so that you can watch it for now, you can revise it for now, as well as you can revise it for future. How to do that part? The steps for that will be shared into the group. You have to complete those steps by the given deadline, and you can see your courses and all the recorded sessions of all the classes which we had till now. Repeating my words, I will not include all the recordings on YouTube. You have to create your account on our web portal for that. That is it for the day. Thank you so much. See you in the next class on Monday. Meanwhile, if you have any questions, Saturdays are doubt classes. You can contact me and we can have a live session as well, or we can have a screen sharing session as well. Whoever has the doubts related to coding, simulation, software. Thank you. Bye bye. Good night.
Okay, good night, sir.